right, everyone, some more notes today. We're going to talk all about covalent compounds. Now, hopefully you've already done the covalent compounds, naming covalent compounds POGL, which means you'll kind of already know half of these notes, but we're going to go through it anyway. So let's dive right in. So as we know, covalent compounds are also known as covalent molecules, and they are made of nonmetals who share electrons. So let's take a look at how to name them. So the first thing when you're naming them, you have to use these Latin prefixes. These Latin prefixes tell us how many of each atom there are. This is really important because many covalent compounds are made up of exactly the same elements, but just in different ratios. So for example, carbon, methane, gas that what do you use methane for? I think methane is natural, mostly what natural gas is. Methane and propane and gasoline all are made up of carbon, only carbon and hydrogen. The only difference between them is how many carbons and how many hydrogens there are. So if we just said carbon, hydrogen, I have no idea what you're talking about. It could be one of thousands of different hydrocarbons. So we have to label how many of each there are. So let's dive right in. All right, so here are the Latin prefixes. I'm gonna read them out for you so you know how to pronounce them. Mono, di, tri, tetra, penta, hexa, hepta, or sometimes septa. You're gonna see both. So you can do either one, doesn't matter. Octa, nona, and deca, all right? Each of those mean, whatever number they say. A lot of them, they should be familiar to you, like penta for pentagon means 5. Hexa for hexagon means 6. Octa for octopus means 8. Deca for like decathlon means 10. Tri for tricycle or triangle. Yeah, this should be kind of familiar. Now, you should be pretty familiar with them, but you don't actually have to memorize them. In fact, you can add these onto your notes, onto your periodic table. So this is the front of your periodic table. We're going to start using the back of the periodic table. So you can add those right here. So go for that. So let's talk about how we can use these to help us name these compounds. So there's a list of steps that you can take. First of all, you are going to use a Latin prefix for each element in the compound, except you don't use a Latin prefix if it's the first one and there's only one. So I'll give you some examples of that. And you have to use mono for the second one. So you always have, the second element always has to have a prefix. The first element does not have to if it's only one. The other thing is that we're going to replace the ending on the last element with "ide." So let's go through a couple of examples. When you're writing compounds, you're always starting with a formula. So we're going to pick the one that we picked from up here before, SCl4. Okay. So that is our formula. So what we need to do is go through. S, looking at our periodic table, stands for sulfur. Okay. There's sulfur. So there's only one of them. So we don't have to have a Latin prefix. So we're just going to write sulfur. Okay. Little arrow there. All right. We're gonna write the next element. We're going to leave a space and write the next element. In this case, it's Cl, which is chlorine. Now, there's a couple things we got to remember about chlorine. First of all, it has this little 4 after it, which means that there are 4 chlorines. So there's 1 sulfur and 4 chlorines. So if we know there's 4, we're going to have to put one of these prefixes in front of it, and it's going to be tetra. So second word, tetra, then it's going to be chlorine, but we got to change the "ine" to an "ide." So chloride. So tetrachloride. So sulfur tetrachloride is the name of this particular compound. And there you go. It's pretty easy. You just do whatever it tells you to do, and you just write it out. So let's try another one. All right. This one might be familiar to you. This is H2O, which hydrogen again is kind of weird. In this case, we're going to say most of the time hydrogen acts as a nonmetal. So hydrogen and oxygen, they're both on our table. There's hydrogen, definitely, probably a nonmetal. Oxygen, definitely a nonmetal. So first thing we got to think about is, all right, we've got the hydrogen. Now the hydrogen has a 2 after it. So this means that we are going to have to use a prefix. So the one for 2 is di. It is the first element in the formula, so we're not going to change the ending. So dihydrogen, that's the first word. The second word is now the second element. So oxygen. Now, first thing, there's only one oxygen. And we know that because there's no other elements afterwards. There's no other subscript, sorry, afterwards. If there's no subscript, it just means there's one. So in this case, we knew that sulfur, there was just one sulfur because there was no little subscript afterward, little tiny letter below. So we now know, excuse me, there's only one oxygen. We have to have a Latin prefix. So for 1, we use mono. Now it's going to be monooxygen, except we have to take the ending and replace it with "ide." So for oxygen, we're actually going to remove the "igen," so it's going to be oxide. The other thing is, if we say monooxide, there's 2 O's in a row. So just to make things, you can do it, it's fine, but just to make it look a little nicer, we just kind of moosh those 2 O's together. So oxide. So the monooxide. The ox is what tells us that it's oxygen. So this is dihydrogen monoxide, also known as water. But there you go. There's another technical chemistry term for water, dihydrogen monoxide. Okay, let's check out maybe one more. Actually, we'll do 2, just for fun. I'll give you guys a second here to try those. I'll give you the answers. So yeah, why don't you take a second? You can just pause this video and you write down what you think the names are and you can compare it to what I do. You can always write in pencil. Okay, so this is a perfect example of why I said that you have to use these Latin prefixes. So you can see both of these compounds are made up of nitrogen and oxygen, but they're not the same at all. They have completely different properties. Nitrogen, this one is, actually, I don't know much about either of these. I think this one's pretty toxic and this one is pretty inert. That's the main thing, like it doesn't really do anything. So NO2 is nitrogen dioxide. And I know that because there's the N, nitrogen dioxide, okay? Because there's just one nitrogen, we don't need the mono in front. We just leave nitrogen as itself because it's the first one. Oxygen, there's 2 oxygens because of that 2 there. Replace the ending with "ide," dioxide. And then this one is nitrogen monoxide. Very similar to the water one, just one nitrogen, just one oxygen, and that's how we would know. So these 2 names are actually different, similar, but different, and it's important that they are so we know the distinction. Okay, so that's naming. You can now do this with any other compounds, but I think we should try writing some formulas. So writing formulas is the exact opposite, and because in covalent compounds, the name tells you exactly what the formula is. So going reverse is actually pretty easy too. So let's check it out. Okay, so writing covalent formulas down here. All right, so let me give you some examples and then we can do this together. I'm just gonna write these down really quickly. Okay, so I just wrote down 3 names here. Let me just make sure we are good. Yeah, we're good to go. Okay, so here's how you write names. Formulas, sorry, reversed. If you have the name and you want the formula, here's what you do. First of all, you write the symbols for each of the element in order that they appear in the name. And then you write the number in a subscript after the symbol based on the Latin prefixes, ignoring ones. So let's give it a try. So we've got dinitrogen hexafluoride. So the first thing we got to figure out is what elements are involved and what are their symbols. So looking at our periodic table, we need nitrogen. Well, nitrogen is right here and its symbol is an N. Okay. Now dinitrogen indicates di is 2. So if you go back up to your Latin prefixes, or I'll just flip onto the back, we know that di is 2. So that means that there's going to be a little 2 afterwards. You'll notice it's below, it's a subscript. That's kind of important. You don't want it to be big because there's going to be lots of numbers. You learned in ions, you can put numbers as a superscript, or yeah, the charge of an ion as a superscript above. We're also going to start putting big numbers in front of compounds next unit 5. So be careful, subscript. Lots of numbers, they mean different things depending on where they are. All right, next step. So that's dinitrogen. The next step is hexafluoride. So if you look at the periodic table, there is no fluoride. That's not an element. However, it's the ending that we use for compounds. So you want to look for something that looks like fluoride. Well, I think fluorine is pretty close. You can tell that you turn the ine into an ide. So this is fluorine. Okay. We'll put the F right next to it so they're close together. And it's got hexa, which if you remember from the back is 6. So N2F6. That is the formula for dinitrogen hexafluoride. All right, next one. Carbon monoxide. Well, that's going to be carbon. Oxide is, or, you know, there is no monoxide again, but the ox kind of rings an ear to me. It's oxygen. Mono means 1. If you remember the front. So this is carbon, CO, carbon monoxide. This is another time you got to be really freaking careful about writing these all uppercase, right? Because C lowercase o is an element called cobalt. And cobalt is extremely different from carbon monoxide. They're not the same at all. So C, capital C, lowercase, uppercase C, lowercase o, cobalt, capital C, capital O, carbon monoxide. Totally different things. One is a blue metal that you use in pigments and a few other things. The other one is a toxic gas. Not the same at all. Okay, finally, carbon tetraiodide. So C is for carbon, tetra is for 4, iodine is the symbol I. It's right here on the periodic table. And then I just means it's the compound. So CI4, carbon tetraiodide. Okay, so that is writing and naming covalent molecules, writing the formulas and writing the names for covalent molecules. So you are now ready to start practicing this on your own. So let me show you the pages. In your unit packet, this is the one I've given you a partial key. I will publish this, I'll post this after a while, so you don't have to like pause and copy like whatever this. Try it all yourself, but you can see that page 1 and page 2 are all about molecular compound is another name for covalent, just so you know. So molecular or covalent compounds. So you are now, your work for today is now page 1 and page 2. And so there you go. Alrighty, well, that's all I got for you today. Be excellent to each other, and I'll catch you next time.